Dr. Alicia Juarrero, is her latest book was Context Changes Everything, published this year in 2023. She is president and co-founder of VectorAnalytica, Incorporated, and a visiting scholar at the University of Miami. Ongoing research in neurophilosophy is focused on the causal role of context-sensitive constraints in the emergence of mental events, such as intentions. We look forward to hearing her. Thank you for participating.
Thank you. Can you hear me? And can you see my screen?
Yes, we can.
Great. Wonderful. Thank you so much. I want to thank the organizers of this conference, as well as all the other speakers, for very enlightening talks. And some of the speakers, I've known their work for years, and I greatly admire them. I am a philosopher. I am not a scientist. My background is in philosophy of science, but let me see. All right. So, but I need to make it go high, and it's not. Screen one. Why is it not advancing? All right, let's see this again. I want to share. Okay, we see if it's this one. Is that better? Did it advance?
It did, yes. Now we see what is the difference.
All right. Perfect. My background, I did my dissertation in ethics, and it was in the difference between explaining and morally justifying behavior. And clearly, for example, one explains behavior. What did happen? Was it a wink or was it a blink? By talking about the causes that issue in that behavior. So if I were to explain a wink, I'd say it's because I threw some dust in your face. Whereas if you are explaining a wink, you would give reasons for the person winking. So in the language of philosophy, blinks are said to be mere behavior because they are intentional and reactive, and winks are intentional and purposive. I'm glad I don't have to go through these in that much of a detail because they've been mentioned very often here. Aristotle, as we do today with computers, used the technology of his time, yes, which was the potter's wheel.
With another treatment.
Yes, exactly.
Yeah.
I've been sort of combining rest and exercise.
Dr. Noble, if you could please mute your account. Thank you.
So formal cause is what makes what I'm making a picture. It's the form of a picture. Material is the clay, the stuff out of which I am making the picture. And then final is the object's goal or purposes. It's been mentioned before, teleology. I do want to point out that Aristotle did not believe in emergence because he believed that final causes as well as formal causes were created ab initio, from the beginning of time. And so even though, unlike Plato, he believed in the reality of change, so he believed in development, he really did not believe in evolution. And Depew and Weber have a wonderful book about this. And efficient cause, I would want to say, is not just the potter's wheel or the carpenter. I'd want to say it is the transfer of energy from the hand of the potter or the carpenter onto the material object. Okay. Now, very important that folks don't seem to remember about Aristotle is that for Aristotle, causes must be external to their effects. That is, for Aristotle, nothing can cause itself. In other words, Aristotle dismissed, refused to accept recursion and recursive causality. And the reason for that is that underwrote his cosmology and could have some prime mover cause the universe. So nothing in nature causes itself. For Aristotle, there are two forms of explanation: episteme, which is deductive, and phronesis, which is not. And episteme is suitable for science because it deals in universals and absolute deductive predictions. Phronesis is not, because when these are contextually embedded, like medicine, ethics, and law, And I would expand that. Anything that is context dependent cannot be fully explained in terms of episteme. The problem is that since 1650, and that's what I call modern, as one of the speakers already mentioned, 3 of those 4 causes were and especially 2 of them were dismissed. Only efficient causality remained in place. And this was a billiard ball, push-pull cause of one thing exerting force on another. So there was only one legitimate form of explanation, and that is deduction, which underwrote prediction, which underwrote universal laws. It fit beautifully with Newtonian mechanism. And in philosophy, that's called the hypothetical deductive model of explanation. So the modern view of parts and wholes is very important. It is a very reductionist notion of wholes. Wholes are nothing but the sum of their primary properties, because only primary properties, masses, are real, and that's where all essentialist traits are supposed to be found. That does all of the causal lifting, if you will, was supposed to be the primary properties. In particular, relational properties, like processes, like anything context dependent, are considered secondary processes. They are derivative. They are not part of the real furniture of the world. From Aristotle on in, context is dismissed. And in a sense, the arrow of time is lost. In action theory, this is the problem with where purpose disappears. In Cartesian dualism, there are separate and distinct events, a cause, a non-physical intention, which supposedly activates a body as an efficient cause. So when I was looking to see how one explained a wink, at the time, we were looking for neural networks that would literally activate the body as an efficient cause. The problem with Cartesian dualism is that these 2 substances, mind and matter, were supposed to exist in 2 entirely separate realms. One was non-physical, one was physical, and according to the science of the time, any kind of interaction between one and the other, meaning any kind of efficient cause between especially the mind, the non-physical, and the physical, would violate causal closure. And not to mention that efficient causes cannot explain standing causes. What I mean by that is I spent the last 42 years intending to write a book, and that is a standing cause, which clearly efficient causes were not considered, were not thought of that way. So you end up with a materialist philosophy of action, and I mean by matter, almost inert matter. One neurophysiological process activates a second, which that's not going to work. Neurological does not show that, and we've been talking about this all day long in this conference. How can neurophysiological processes efficiently produce behavior such that it is meaningful matter? Where does the meaning come from in this understanding of matter, which is as a passive, unformed phenomenon, or much less purposive? So the main problem with contemporary action theory, how can we explain intentional behavior, an action? I intend to do whatever. How can these embody a meaningful intention, which then top down issues in meaningful purposive behavior? A wink, not a blink. And the answer is it can't. Because although we bemoan the loss of formal and final cause in Aristotle, notice that nobody in the last 8 hours has mentioned the disavowal of recursion and circular causality, which goes back to Metaphysics 8. So all the paradoxes of self-reference, all the business about activating oneself, all of this is gone too. And what that means is that there is no modern understanding. See, the problem with modernity is it got rid of formal and final cause, but it kept the disavowal of recursive circular causality. And as a result, there is no way to explain how parts, individual independent particles, can interact to produce coherent totalities that hang together as a unit, which obviously formal cause for Aristotle did the job, but we don't have that anymore, and so we cannot explain coherence. That is the reason why John Donne, more or less writing at the time of Newton and Descartes, writes all coherence gone in that beautiful poem. Of course it is. On this modern view of cause and explanation, all coherence is gone. Kant recognized this. I am very pleased that everybody is starting to recognize this about Kant, because what I was looking for as far back as the mid-80s was some kind of process, some kind of, I'm going to use the mechanism, the word mechanism in a very broad sense, to simply mean what is it that can allow particles to interact to produce wholes, to then in turn reconstitute itself through those parts or instantiate itself in the as an instance of with those parts. And Kant, in the critique of judgment, the third critique, which everybody forgets, because remember, he had been awoken from his dogmatic slumbers by Hume, and he really, as one of the speakers mentioned, believed that the constitutive category of the understanding gave us basically Newtonian mechanical forces. He says, understanding the intrinsic purposiveness of living things. The critique of judgment has a section called the critique of teleological judgment, and that's where this is taken from. He says, requires a kind of causality unknown to us. And what I just happened to read the critique, talk about one's journey. I happened to read the Kant's critique of judgment more or less in the same week that I read Prigoghine's popularized book with Isabel Stenger, Order Out of Chaos. And I thought, oh my goodness, I think I've got a model that got the Nobel Prize, so it's not voodoo science. The Western scientists won't hit the roof about it. It allows me to reconceptualize mereological parts to whole and whole to parts causal relations. Right? Now, for example, autocatalysis is a recursive process. And yet, it doesn't bother anybody. But in a sense, it's because folks who start using, biologists were the last ones to push back on Newtonian notion of science and efficient causes and so on, because they understood the circular relationships that occur in nature. But it's curious that anytime they start speaking about this, they quickly leave the term cause, because I think that's a losing proposition. I think I've left that to the scientist, and I will let them to have the word cause to mean efficient causality. But as soon as they mean something else, they start talking about constraints, factors, conditions, and all sorts of other words that give them a sort of recursive causality, but doesn't fit standard causality. So what I have been arguing for since the first book called Dynamics in Action that MIT published for me in 1999, I've been advocating a new theory of interlevel causality as constraints, because I think that gets me a way to reintroduce forms, a formal cause, a final cause, without running afoul of Western science. So this one was published in '99, and this is what I'm looking for. I'm looking for some form of interlevel relations that bottom up can organize individual, previously independent particles into complex dynamical wholes, which are qualitatively different, which exhibit irreducible emergent properties, but which are not other than the components that make them up. Please remember, in efficient cause, the cause must be other than, separate and distinct, so spatio-temporally distinct from the effect. But clearly, if we're talking about the self-organization of the dynamical whole, that is not a fused block, but rather is what I call multiply realizable. That description has been, I think, used here in using the terms, it is unity in differentiation. But what I want to say is that those complex dynamical systems are not epiphenomenal. See, another implication of the modern notion that apparent wholes are nothing but the sum of their parts is that then those apparent wholes, W-H-O-L-E-S, are epiphenomena. They are causally powerless, which means what? I cannot explain action as behavior that issues from a higher level of organization and intention and mental processes. So what I would like to say is that I'm looking for a phenomenon that can give me a global dynamical, Charles Dyke used to call these structures of processes. We could call them dynamical networks, we can call them, but that actively can, notice I'm sneaky, I've used the word influence. We can use the word modulate, we can use regulate, but as soon as you say causal, you will turn off most of the Anglo-American Western scientists. So, and that selection criteria is determined at the emergent and systemic level, which fits with, I believe it was Professor Noble's phrase that as the higher up you go, the freer you are. Right? Whoops, back. So I want to say that I want a theory that can explain to me how a whole can cause itself to change and behave in certain ways while staying itself as a whole. And I believe that I can do that in terms of the language of constraints. So what I will define as constraints are conditions or factors that change the probability of other events and processes. They facilitate or regulate energy transfer, but they don't themselves impart energy. And I'm thinking of things like catalysts and feedback loops and so on. Constraints are conserved. And I believe some forms of constraint are able to generate emergent levels of coherence that are each characterized by distinct novel properties. And of course, I am assuming, as with Prigogine, that we are talking, as Professor Turner just mentioned, open systems far from equilibrium. These are not near equilibrium thermodynamic systems. They are far from equilibrium electrodynamic systems. So what I did in the first book in 1999 is borrow from Lila Gatlin and talk about two forms of constraints. In that book, I used the word context-free constraint because Lila Gatlin had used context-free, and I got a lot of grief from people saying there's nothing that's context-free. So I said, okay, how about we use the term context-independent constraint? And the way Lila Gatlin defines context-independent constraints is she says, those are conditions that take a system away from randomness. So clearly, if you have situations, if you have white noise, everything's random, there can be no complexification happening. In fact, if you are near equilibrium, because there are basically none of these constraints that are strongly at work, everything quickly devolves towards the classical thermodynamic notion of equilibrium, which is basically stasis, right? Examples that I want to suggest for context-independent constraints would be gradients, polarity, charge, boundary conditions. In a sense, what I view context-independent constraints as setting up is a field, a possibility space within which something else was going to happen. Why not just limit the notion of constraint to these phenomena, to these context-independent constraints? Because I think context-independent constraints do not by themselves give you complexification. They set the background for something else to be possible. Example, in the early cosmos, if inflationary period is in fact so, if all dissipates into the void, then you won't get complexity. It will all dissipate into nothing. If, on the other hand, you look at space-time as a gravitational well in Einstein, then if everything were to be sucked into a black hole, it would explode and you wouldn't get complexity either. So what I believe you need is, in addition to context-independent constraints, given a background of context-independent constraints, in other words, given that you've taken the system far from equiprobability, so you're now far from equilibrium, context-dependent constraints, I think, can kick in, if you will, at that point. Lila Gatlin defines context-dependent constraints as those constraints that take a system far from independence, so they connect events to each other. Please remember, back to Newtonian mechanics. Newtonian mechanics are Markovian. The future does not remember the past. I sometimes think of mechanical forces, the forceful impacts of one billiard ball on the other is they move things, but they don't change anything. So in a sense, they take a system away from independence, but then, you know, things reassert themselves. But for example, in language, a very easy way of explaining context-dependent constraints, and I include temporally dependent constraints as well as spatially dependent constraints, is, for example, in English, given that a Q appears, a U is more likely to happen next. So it fits my example of a constraint as changing the probability of what's going to come next. But I think that is so for catalysts, for feedback loops, timing, which I think if spatial context-dependent constraints are often ignored, temporal dependent constraints are even more ignored. For example, timing. In the second book I wrote, which was published 6 months ago, also by MIT Press, I mentioned the notion of timing, and I use as an example a playground swing. A child will learn very quickly that when he or she kicks, the moment in which he or she kicks is as important as the amount of energy they impart into that kick. But the timing, the moment, does not itself impart energy. It's not an efficient cause. It cannot be handled by classical modern causality. I would say, since we spoke recently about interfaces, that interfaces function as a form of context-dependent constraints. They interconnect the outside with the inside. So I would want to say that first-order context-dependent constraints, such as catalysts and feedback, make behaviors of the parts depend on what went before and what is occurring around them. Why is this important? Because context-dependent constraints can embed, can carry out embeddedness. See, again, in Newtonian science, which is what I consider modern science, in modern science, space and time are featureless, empty containers. There is no such thing as embedding a phenomenon in its context. The context is separate from and supposedly acts on the thing as an efficient cause. No, that's not what a niche does in biology. That's not what a cell does for the organelles in it. But context-dependent constraints allow me to have a form of logic that makes previously independent particles interdependent and embed them in a system. Now, what I would like to say is that context-dependent constraints that enable a whole that is not other than the components, but has emergent properties that the components don't have, I want to call those enabling constraints because they enable complexification. They make complexity possible. And I think this is the mechanism that allows novelty, that allows emergent properties, which I think even Aristotle, because he believed that forms and purpose and bios purpose were built in from the start, from creation, he could not allow for evolution. This allows me to understand a way that complex systems that nature is creative and can produce complex systems with emergent properties that are qualitatively different from their components. So first order context, the logic of constraint says that first order context-dependent constraints generate systems, organisms, communities, in other words, wholes, W-H-O-L-E-S. In other words, complex-dependent constraints are the origin, the source of those higher level of organizations that we've sort of taken for granted in our discussion here. And this is very common, I think, because in general, the term constraint is usually used to mean only restrictive, top-down, restrictive, limiting the space of possibilities. But I borrow enabling constraints from biologists like Howard Patty, like Stan Salty, an awful lot of these early thinkers in hierarchy theory from biology were perfectly comfortable with the notion of enabling constraints that generate higher levels of organizations. If this is so, if you have emergent properties at the higher level of organizations, these higher levels are qualitatively not merely aggregates. They, in fact, have an expanded space with greater dimensions of freedom. The whole can do more than its parts, but it is not other than its parts. But if you are stuck in a modern, scientific, atomistic, reductionistic, efficient causality framework, you can't explain that. Whereas things like lasers have properties they can cauterize that individual photon streams cannot. So there is clearly a way of now understanding the emergence of qualitatively emergent properties. And in complex dynamical systems theory, these are often called complex attractors. And because, as Prigogine won the Nobel Prize in chemistry by showing that these dissipative structures, such as Bénard cells, dust devils, hurricanes, as well as BZ reaction, I'll talk about these a bit later on, they persist because they create order, and it's a metastable form of equilibrium disorder, and that this is why they can persist. So I would want to say that strong emergence, meaning emergence that is not epiphenomenal, is the generation of higher levels of organization and the establishment and closure of what I call a constraint regime. I don't know what else to call it, but it is a set of interlocking interdependencies. Might want to call it a network of constraints, but again, I'm always thinking dynamical processes. I used to joke around and say that the worst thing that happened to philosophy was that Parmenides won and Heraclitus lost, and it was the end of philosophy from there on in. But in any case, I'm always thinking dynamical process. These are interlocking dynamical interdependencies of context-independent constraints acting as a background, but not independent of, but working together with, affecting context-dependent constraints and vice versa. And so each new coherent dynamic, Ernst Sazmary, the biologist in Hungary, says that with Maynard Smith, said that major transitions and evolutions all mark the appearance of a new coherence. So be it a self, a society, is a novel regime of dynamical constraints. The logic is analogous. The individual emergent properties at each new level of coherent have unique properties. So these constraints nest. I absolutely agree with this suggestion that's been made several times today. They nest as holons. Remember Kessler's idea of a holon as parts are holes and parts. They face both ways. But I also think they're not just holons where the influence goes vertically. The influence also goes horizontally among phenomena that exist at the same level of organization that can interact among themselves. But once a constraint regime that generates a holistic totality that can hang together like an organism, that constraint regime has double duty. It functions, it has two ways of operating. As constitutive constraints, that constraint regime stabilizes that higher level of organization. But I'm not reifying this. I'm not saying it is a thing, a stuff, a particle, unless you want to think of a particle as a condensate of constraints, which I probably do want to think of a particle more as a condensate of constraints than as a thing. This notion of matter as passive and inert, that's very recent too, but anyway, that's a whole different story. So they stabilize the higher level of organization, but they stabilize it in a metastable sense. When I use the term stability such that it persists, I'm thinking, for example, like a tightrope walker on a tightrope. There's a constant adjustment of those constraints, whether they're coming from the possibility space, like the wind increased, or somebody's distracted me and I've got an itch that's distracted me and I can't seem to, but there's a constant adjustment of constraints. So rather than efficient causes, I want to say constraint regimes are a constant dynamic of self-adjusting, interdependently adjusting constraints. And in particular, top-down acting as governing regulatory constraints, they regulate, modify, and otherwise control. Maybe you want to call them, they keep, for example, the individual photon streams aligned in the case of a laser, the components of which that constraint regime is composed. And since cancer was mentioned here more than once, I would want to say that when constraint regimes weaken, then the individual components slip the control of those constraint regimes go rogue, and that's where cancer occurs. And so this idea of constraint can give me a way of a logic of understanding not only how constraints can regulate and control top down, but also how those regulatory dynamics emerge to begin with.
Dr. Juarrero, if you can conclude in 5 minutes.
Yes, I think I will. So acting of governing constraints or constraint regimes implements, in a sense, second order context-dependent constraints from the whole to the part. They do so by reducing the component's degree of freedom, and as a result, the behavior of the individual parts or the instance in question is subtly constrained by spatial-temporal context, history of the attractor in which they are embedded. And this is the way intentions operate. I would say the emergent properties of the context-dependent constraints in a living, especially in a human being with a neural system, against all the background of their history and evolution and everything else, embodies emergent properties of consciousness and meaning as neurons self-train and self-organize, and intentions are neurologically embodied and enacted in such global structures. And this is how, I'm saying that again. And this is how intentions and purposiveness emerge in human beings and cause action. But I want to say, and I'll go through this very quickly, I would want to restrict the term purpose and consciousness to human beings. I would be perfectly happy to say that there is top-down regulation prior to the emergence of life. The fourth step in a busy, purely chemical reaction is autocatalytic. It drives the system far from equilibrium. At an instability, a bifurcation occurs. It drives the reaction to a brand new mode of organization with emergent properties, which are waveform-like. Thank you very much, Dr. Turner. I absolutely agree with that. I think emergent phenomena suddenly are analog, even if the components may be digital. I think the emergent dynamics are analog. And so the logic of explanation suitable to dynamical system is that we must take all levels of context seriously. We must take history, initial seriously. We must, oftentimes it can only be done retrospectively, only tentatively and very provisionally. And since this was mentioned during one of the talks, we must take the perspective of the scientist, or if you wish, the experimental apparatus seriously, because the observation leaks into the observed. That's the logic of explanation. What I was doing earlier was sticking my neck out and taking a stab at speculative metaphysics, if you will. So, and this is the new book, Context Changes Everything, and the new chapter is all about what went wrong, and hopefully the rest of it is how constraints create coherent dynamics and how that can explain so much of what we can't explain through Newtonian, very modern science. Thank you very much. Thank you for inviting me.
Thank you very much for your detailed and enthusiastic, rational presentation, which coincided with many of the talks given here today so far. I spoke directly to them. Hopefully we have some comments or questions from the audience. We have 10 minutes before the interdisciplinary dialogue, where hopefully we'll have very nice exchange amongst most of the presenters today. And also, if you could just stop sharing your screen.
Oh, I'm sorry. Pause share. Okay.
It's still there.
Stop share. Okay.
There it is. Yep. Thank you.
I would like to come in with a comment on the presentation by Alicia. I think it's really beautifully presented. This, of course, brings out very clearly indeed that there are multiple forms of causation. We've known that all the way from Aristotle onwards. And it really makes, I don't know how best to put it, it is absurd that so many scientists, wedded to a mechanistic view, simply think that the only form of causality is the efficient cause. It's so obviously a crazy way of looking at the situation. So thank you very much for your presentation. Very clear, and I will obviously want to see the new book.
Thank you. May I reply to that comment? I think that biologists would obviously agree with you, and you know, biologists, physiologists, and so on are perfectly happy with this. The problem that I think standard physics would respond is that, but there are no universal laws coming out of biology. And I think the answer to this, and of course, they have a whole edifice that universal laws must be underwritten by projectable predicates. This whole is the logic of philosophy of science. It goes all the way back to this, and the projectable predicates have to be applied everywhere. And as soon as you start talking about things like pieces, for example, one example was given, a piece of what? Yes, but the problem is a piece is an indexical. It automatically implies a context, and therefore a physicist would say that's why the concept of piece, P-I-E-C-E, doesn't fit into physics. So if this is correct, then what this suggests is that, in a sense, a contextual physics has to be taken seriously. That what happens in complexification, and the reason I like the notion of constraint is that I am not limited to the notion of life, because as Dr. Turner was pointing out, well, where do you decide what's living or not living? But that's also true, for example, for tornadoes. I used to joke with Stan Stolte, who's a evolutionary biologist, developmental biologist. I would say, look at the way they name hurricanes. And the reason they name hurricanes is because they have these unique trajectories. They are responsive to the unique context out of which they emerged. They are dissipative systems par excellence, all right? But what that means is that you've got to then conceptualize possibility space as rugged. In a sense, physics has to think of space the way Waddington's landscapes helped us imagine an epigenetic, evolutionary, developmental landscape. And I think physics is far from doing that still. The idea that, you know, you are going to be able to have a theory of everything that will account for everything is still very powerful in the minds of physicists. I think, though, that chemistry is starting to lose its footing there a bit, because, for example, although I can't remember which of the talks spoke about chemistry as part of matter, and maybe it was Dr. Turner now at the end where you're saying, well, that's part of the atomistic. I'm not too sure of that. I was shocked when I was writing this second book that we don't really understand what molecular covalent bonds are. That covalent bonds, in fact, might be the synchrony and entrainment of the dynamics of shared electrons. Well, by golly, that's what we're talking about. Isn't that also what a laser is? It's the constraint regime of the interactions among a number of previously independent particles that now possess emergent properties. So the molecule can do more than the atom can. And if I strongly recommend Philip Ball's most recent book called How Life Works. Molecules within cells in elephants work completely different than molecules within cells of single-celled organisms. So even the same cell doesn't work the same way. So again, they are constrained at all levels of organization, and there's quite a number of those levels between the prokaryote and us. So I would want to extend this, I would almost want to say it's constraints all the way up and all the way down, in a sense, because it's wider than just a physical. It includes physical side, but it goes wider than that.
Just to clarify, this last response from Dr. Juarrero is from a comment written in the comment section by Dr. Dennis Noble, which reads, interlevel causality is part of what the principle of biological relativity is about. The higher levels set the boundary conditions that constrain the lower levels. This is a necessary feature without which any kind of computation by the lower level is impossible. These are your conditions and constraints. Such constraints are indeed enablers. Totally agree. Dennis.
Yeah, that's how the higher levels emerge. And so it's enabling emergence up, and then constitutive constraints that allow the system to persist over time, which is why, for example, I would prefer more the example of, instead of the cauliflower and the cloud, the cauliflower and the Bénard cell, or something like that. Because clearly clouds do not have a closure. They're completely determined by the external condition. See, I want to make a distinction between context and environment. I think the environment can be perfectly nicely understood in terms of efficient causality. So when a tsunami wipes out a village in Indonesia, boy, that's an efficient causality. Wipe the thing out. But when we talk about context, we are not talking about efficient causality. We're talking about these kinds of interlocking, interdependent relationships and conditions that change each other's probability distribution to produce a higher level organization that can access degrees of freedom, therefore have its emergent properties that the components by themselves don't have, which tells me that, if anything, that the universe, reality, nature, I don't care what you call it, has a disposition towards coherence creation in terms of constraints that modern science simply could not fathom, could not handle, and disallowed.
I'm not sure if Dr. Noble had any response or if there's any other comments or questions from the audience. I did have one small question myself, but I would like to wait in case anyone else has a comment or question. Dr. Turner, perhaps, did you have any? No? Okay. So I just wanted a little more clarity about something that you mentioned at the end, where you said you would reserve purpose and consciousness for humans. So I wonder what is behind that. Now, we saw some videos from Dr. Brian Ford where, the cells, a single cell was eating some things and not eating other things. So we agree that there is a distinction between, consciousness and perhaps cognition for lower level organisms and cells. And also something that Dr. Bhakti-Madhava-Puri is also aware of is, this distinction of anthropology, how obviously at the human level of life, there are distinctions that are not there at the lower levels of life. So we're just curious about your take on that.
I'm not familiar with the Vedic tradition, but I did know that it's a lot more sophisticated than modern science, in that there are a lot of different concepts that capture the nuances of the different forms of what I would want to call top-down control. It would seem to me very clear that the single-celled organism that Dr. Ford presented is a unitary totality, a whole, that has autonomy and agency in the sense of those interlocking dependencies persist even when there are minor differences in the components of that organism, when it swallowed something else, or when the environment changes a little bit. So it clearly has a constraint regime that top-down controls and regulates all its activities such that it persists as that entity. I suspect that every time Western scientists see top-down causation, they immediately want, I think maybe unintentionally, assimilate it to consciousness because maybe they still operate in a unacknowledged Cartesian mind, world where, oh, this must be Cartesian. Oh, but if that's so, then it has to come from outside. No. What I want to say is top-down causation occurs all the way from the abiotic realm to the level of humans, to the level of the psyche, to the level of society, to the level of the biosphere. And that at each level, there are unique and different properties, emergent properties. And I would prefer to make sure that the language we use reflected that nuance. Whereas using the word consciousness all the way down seems to me to water down that specification. And maybe it's my fault that I'm still thinking in a Western scientific mode and can't get used to not doing that.
We mentioned at the introduction of the conference also that just an etymological view of the difference between cognition and consciousness also seems to show a difference. So, there may be some justification and for multiple different angles of vision there. Now it's 2:47 and the floor is open for this interdisciplinary dialogue.